This video is designed to explain a little bit about adding and subtracting fractions. Of course, adding and subtracting is essentially the same thing, so we're mostly going to be talking about the reasons for getting a common denominator and how to perform this operation and add fractions. So, given a very simple problem of 1/2 plus 3/4, we can't simply add the numerators together and get some answer because we're dealing with different size pieces. If you look at the sketches below, the red section would be 1/2 of an entire pie or pizza, for example, while the three blue sections would represent the three 1/4 size pieces of a pie or pizza. So to ask the question, how many pieces do we have? You really need to say, how many pieces do we have that are all the same size? So in order to make them the same size, you have to get a common denominator, which means you're cutting the pizzas into the same size pieces. So in this problem, it's fairly simple to be able to say, we want to do this and chop the pizza up into quarters as our other pizza is chopped up into. So now they're the same size pieces. Well, that 1/2 of a pizza is now 2/4 of a pizza. So this 1/2 guy turns into 2/4. And that comes from basically doubling the top and doubling the bottom. So you could imagine you're multiplying the top by 2 and multiplying the bottom by 2. What you're really doing is you're splitting the original fraction into the same size pizzas, the pizza or the pie or whatever it is into the same size pieces. So now we have 2/4 and 3/4, which means we can now add the numerators because what we're doing is we're simply counting 1/4 size pieces. So what that means is we have 2 plus 3 1/4 size pieces. This is, of course, 5/4, also written as 1 and 1/4, because 5 full 1/4 size pieces is a whole pie plus one more quarter. On the next slide, we'll show a more complicated process where we have to get a common denominator, and they do not share a common multiple. So here is a slide that shows another addition problem, 3/5 plus 3/4. So to get a common denominator, it's best to look for the least common multiple of 5 and 4. In other words, if you have a pie that's split into fifths and you have a pie that's split into fourths, how would you keep chopping up those pies to get the same size pieces? Well, that would be 20ths, because both 5 and 4 go into 20. It's the smallest number they'll both go into in this case because they share no common factors, which means that what we're now doing is we're saying, what do we multiply 5 by to get 20? Well, we multiplied by 4. So what do we multiply 3 by to get 20? We multiply by 4 as well. In other words, we're simply coming along and multiplying the top and the bottom by the same thing. When you're doing this, you're actually multiplying by 1 because 4/4 is 1. So anything times 1 is itself, which means 12/20 and 3/5 are equivalent fractions. They're equal to each other since we simply multiplied 3/5 by 4/4 or 1. Similarly, we're going to ask ourselves, what do we multiply 4 by to get 20? Well, that's 5, so we must multiply 3 by 5 to get the numerator of an equivalent fraction, and that means we get 15/20. This, of course, allows us now to say we have 12 1/20 size pieces and 15 1/20 size pieces. So what we have is 27 1/20 size pieces, which of course can be turned into the mixed fraction 1 and 7/20, should you wish it in that form. Finally, here's a fraction problem with a subtraction with two denominators that are not common, and we're looking for the least common multiple. And what we need to do is recognize that 12 and 9 share the factor of 3, which means we can look for a smaller number than the product of 9 and 12, which is 108, but rather we can look for 36, and we can formally learn how to do this, but most of you should be able to come up with the least common multiple, or at least a common multiple that's efficient, by doing it in your head. So what did we multiply 12 by to get 36? 3. What do we multiply 5 by to get the numerator then? Also by 3. That gives us 15/36 for the equivalent fraction. And we ask ourselves the same question for 1/9. We multiplied the denominator by 4, so we multiply the numerator by 4. Remember, we're just multiplying by 1. That gives us 4/36. So 1/9 is equivalent to 4/36, and 5/12 is equivalent to 15/36. When we add those two together, and we're actually adding a positive and a negative number. This is simply 15 minus 4, or 15 plus negative 4. So we have 15 minus 4/36, and that is 11/36. Now, generally speaking, you want to ask yourself the question, can I reduce that answer further? And the answer in this case is no. This is fully reduced. And the reason is there's no common factor in the numerator and the denominator that can be canceled. The numerator is simply 11 times 1, if you wish to factor it. And the denominator is simply some 2's and 3's multiplied by each other, because 36 is built out of 2 times 2 times 3 times 3. So it's fully reduced because there's no common factor that can be canceled in the numerator and the denominator.